Now let's look at the variance or standard deviation of a set of scores. Now these are measures of spread, so they show how far on average each score sits away from the mean. Standard deviation can be represented with an S, or this omega symbol, and it's the square root of the variance, which is shown by S squared, omega squared, or we've already seen it in our probability distributions unit as the variance of X, and it can be written like this. So generally you'll find the variance first, and then you'll take the square root of that to find the standard deviation. Now, we already learned two different formulas for variance when we worked with the probability distributions. The first one made a lot more sense when we were looking at conceptually what it means. So to revise this first, we looked at adding up all of the squares of the differences of each score from the mean. So we said, how far is each score away from the mean? We'll square that so it's positive to take into account that some are below the mean and some are above. And then we multiplied it by the probability. In other words, we let the chance of it happening weight that difference away from the mean that it was. Now, another way of writing that, and in fact in your syllabus reference sheet that you get for your exam, it's written as the expected value of x minus the mean squared. Now, why is it written this way? Well, when you weight something by the probability and you add them all up, that's the recipe for how you find the expected value of something. You weight it by the probabilities and then you add those all together, and that's the expected value. So we're finding the expected value then of each thing minus the mean all squared. And that's one of the formulas that you have on your sheet. The other version of it, which generally is a little bit easier to use, and the reason it's easier to use is that the mean is often not a whole number. So if you've got to look at every single score and subtract the mean from it, and the mean is some nasty fractional decimal, you end up with a lot of sort of yucky numbers to work with. So calculations are a lot simpler a lot of the time when you use this formula. So this formula actually says, well, let's add up all of the x squareds multiplied by the probabilities, and then when we've done all that adding up, let's just subtract the square of the mean. Now we've already been through a proof to show that this formula is in fact equal to this one, so we're not going to look at that again. But this formula is written on the formula sheet as well. You get both of these ones in purple, and yet when you go to apply them, it's really handy to know the version in black, because that's what you can actually do. This is saying find the expected value of x squared. Well, that makes sense because expected value says add them up, weight them with their probabilities, and that's what we're doing here, adding up and weighting each x squared with its probability. And then it says to subtract the mean squared, so that part's the same. Now, we don't want to reinvent the wheel. We've got these formulas all ready for variance, and they work with probability distributions where we're always using probabilities in the calculations. So when we're working with basic data applications that don't involve probability, we need to just alter these a little bit. So looking at that same data with the siblings and the number of people that had that number of siblings, we can calculate variance two ways. And this is calculating by hand. Later on we can see how we could actually use our calculators to find it more simply. But it's important to be able to calculate by hand at this stage. Now the first formula we said makes a lot more sense with understanding what variance really is. We take each score and we subtract the mean. We square the differences, multiply by the frequency, divide by n. We have to add all of these up. Now we've already seen that the mean is 27/15. So what I would do if I know I need to use that over and over again is I'd store it in my calculator. Easy way to do that, 27/15, hit equals, and I have it in there. Now to store it, I hit Shift, and I hit this RCL button because the yellow function says STO, which is store. And now I choose a button to store it as, and I'm choosing out of these red buttons here that say A, B, C, D, E in red. So I'm going to store it as A. Now it says answer is equal to A. I can go about my business and do anything else I like on my calculator. When I want A, I hit the red alpha button and then hit A, and A comes up, and I can square it or subtract it or do whatever I like. Now, rather than copying down this part, let's just leave it and have a look at how tedious it was and make a decision that for most of the time it's going to be a lot easier to use Formula 2. Here I've had to take each score, so 0 minus the mean, 27/5, and then square it. Sorry, I've circled all the 27/5, so it looks a little bit messy. I've then squared it, and then I've multiplied it by the frequency. And I've done that each time. So here I have 1, minus the mean squared and then multiplied by 4. So there's lots of chances to make a mistake on your calculator when you're putting all of this in, and it's really long and tedious even just to write out. The answer I come out with is 1.226 repeater. Now, formula 2, a lot easier to use. I can do a lot of the calculating actually in my head. It says square each score. Well, these numbers are very easy for me to square in my head. Multiply each one by the frequency. Again, that's simple times tables. And then add them all up. Put them over the number of scores that there are. Then subtract the mean squared. So all of this part's really simple. Square this number, 0, and multiply it by 2, I get 0. I'll just do that part in my head and write it down. Square this, 1 times by 4 is 4. Square this and multiply by this and you get 20. Square it, multiply by 3. Square this and multiply by 1. And now I can actually just put this part in my calculator, so much quicker and easier to do, and I get the exact same answer. So at the end of this process, we found variance. The second formula was definitely easier to use in this case. And if we then want to find the standard deviation, it's actually just the square root of the variance. So keep this answer in your calculator, find the square root of it, and in this case, we have a standard deviation of just over 1. So I've rounded it off here to 3 decimal places. It's 1.108. Now, what does this mean? It means that on average, these scores of how many siblings each person in the class had was a little more than 1 away from the average. Now, obviously, nobody was 1.1 away from the average because you can only have a whole number of siblings, but it gives us an idea of the average spread of the data.